All right, I'm going to show you a little trick here. So we're on a 60-degree angle. The goat, I'm going to use this dot here, has a weight straight down, force of gravity, straight down the center of the earth. The force normal is perpendicular to the surface. The static friction prevents him from going down. So the motion is down the hill. Static force of friction, static is up the hill. Since this is not accelerating, these all equal 0. So let me show you a little trick. If I can add vectors, so I'm going to bring the blue one down and go tip to tail and make that a 90-degree angle. This is force normal I'm adding, and this scale is probably off. But, whoops, wrong color. Wouldn't my force static have to go right back to where I started because I have a complete complete net force of 0. So if nothing else, we know the 60-degree angle is down here because I kind of taught that to us a while back. That's a 60-degree angle down. Without any numbers, I'm kind of stuck. Oh, I do have a number. My force gravity is 900. My wife's home. Everybody say, hi, Mrs. Ramthen. Hi, Mrs. Ramthen. All right. So let's find the force normal, which is in the blue here. It is, if this is a right triangle, I have hypotenuse and adjacent, which is cosine. So the cosine of 60 degrees equals adjacent, which is force normal, divided by hypotenuse, which is 900. Get force normal on both sides. It's 900 newtons times the cosine of 60 equals force normal. Throw that in your calculator, and you're going to get a force normal of 450. All right, now let's find the force friction static, which is opposite. So the sine of 60 equals opposite, which is force friction static, divided by hypotenuse, which is still 900. To get the force friction static all by itself, you have to multiply both sides. Not cosine. Sine of 60. And that's force friction static. And 900 multiplied by the sine of 60 gives me a bigger number. And that's about 779. I probably should have written down 780, but 779. This only works because it's at static equilibrium and all the forces equal 0. So all of my forces go back to that red dot there. So I start at the red dot, go down to there, from there over with my force normal, and then back up to the red dot. 779 for that. Woo woo. Actually, you know what I should do here is there is a different way to do this where you tilt your axis and you call that X and this Y, and your force gravity goes down, your force normal is on top of the Y-axis, and your force friction static goes up your Y-axis there. Did I say Y? That's X. This is Y. It goes on your x-axis, and you can do some geometry of probably some 60-degree angle. You can figure this out with a 60-30 triangle, and if you know that one, you can get these. And if we, why am I using the same color? I have an x component here, which would equal, these two should equal, and then I have a y component here of this hypotenuse down here, and these two should equal because of static equilibrium, but I like my way better. Woo woo, woo woo.